In this video, I'll be taking you through Upstyle Backdoor, which is a challenge on Let's Defend platform. So just come to challenges right here and click Upstyle Backdoor. Here, right? So here we see this. Help us to analyze specifically targeting a backdoor known as Upstyle and its relation to CVE, common vulnerabilities and exposures that affect Palo Alto Networks products. So here we have the file location. We have this zipped file that we'll look into. These inside this virtual machine, and this is the password right here. So let's click to connect for a lab environment to load, and we have a captcha here. So let's click all the hats. Okay, that was successful. So the environment is loading. I'll give it time, and I'll be back when the virtual machine is up. So virtual machine is finally up. But let me just give you a quick overview of what this Upstyle Backdoor is. So Upstyle Backdoor is a Python-based backdoor which was discovered in April 7th by Volexity. Volexity is a cybersecurity firm based in DC. So this Python-based backdoor was used in the zero-day exploitation of a vulnerability in Palo Alto GlobalProtect firewall devices. So the zero day allowed for unauthenticated remote code execution. So the backdoor itself was meant to allow the attacker, whom was known as UTA 0 to 18, to execute additional commands on the device via specially crafted network requests. So the CV given to this particular vulnerability was CVE-2024-3400. You can check it here. I had searched for this. These are Volexity's website. They have a detailed explanation of the zero-day exploitation, this particular CV right here, and you can read through it and get much of insight from it. I'll leave a link to this particular website in the description below. So let's continue. Before we go any further, let's open this in a new tab. So just click there. I'll have a new tab. I'll have to view it in a larger tab. Okay, it's connecting. Okay. So here, let's go to this particular directory. If I can find my mouse right here, okay. Double click on that to open this particular directory. Then here we have this sample.zip, this zipped folder. So my mouse is kind of disappearing, but let me see. Okay. Okay, left click on that. Not there. Come on. I can't seem to find my mouse. Okay, I've gone to the wrong folder. Can I just close this? Let me close this. My machine is touchscreen, so I can just tap on this if my mouse is misbehaving. So let me just double tap on that. Then right here, what I'll do, since I need to right click this and I can't seem to find my mouse, let me go back to this and see if I can find my mouse easily. Okay, it's the same case. Let's let me double tap on it and see. You need to extract it and view it with the notepad. I guess it's because I already extracted it, but extract it and right click and open it with the notepad. Let me see how it will open up. Okay, I can't even type the password right here. The virtual machine is misbehaving, but let's see. So the password should be infected. I'll type that, then I'll click enter, because I'm now working with without a mouse, and that doesn't seem to work for me. Let me go back here. Why is the mouse disappearing? Come on. Okay, let me drag it there carefully. No, it won't. Okay, here. I'm being careful with it. No, it moved again. Okay, I think I got it. Then let's click edit with the notepad. I'm being extremely careful because the machine is misbehaving. Okay, if you face the same kind of problem, you can just do the same thing. But why am I seeing gibberish happening? Well, let me minimize this. Oh, come on. Come on. I'll just have to try and be careful with it. The machine is really misbehaving. Tap that carefully. Control R. Then okay, extract all. Then come down here to extract. I'll just tap my screen right there. Okay, then I'm tapping my screen because the mouse is misbehaving. I'll just double click on that. Then you have this sample.py. You can open it with a notepad. You don't know if it has already opened. Let me right click, then edit. Come here to edit with notepad. I hope you guys are not facing the same problem I'm facing. Okay, and here we have it eventually. So can I maximize it? Okay, we have that. So here we have this particular script right here, and let's just get on to the questions. And okay, what function is responsible for monitoring a log file, for embedded commands and executing them while also restoring the file to its original state? So we're looking for the function. The answer format should be function name. So that function is this particular check function right here. On line 5, since my mouse is misbehaving, I'll just be reading the lines. It's on line 5 right here. This particular that line 5. So this check function is responsible for log monitoring, command execution, and restoring files. So let's just come back here and answer that. Check, submit that. It's taking time to load. Okay, that's correct. What is the system path that is being used by the threat actor? So the system path is what we have right here on line 2. Let me get back here, a bigger screen. On line 2, we have this system path here. And this system path, here the code starts by modifying the system path file, which is typically found in Python's library path. So the script writes an encoded payload into the system path, effectively inserting custom code that will run whenever Python loads this file. So this target can grant persistence across reboots or service starts. So it's this particular, can I really copy it really now? Let me see if I can grab it. Okay. Can I? Let me see. Come to clipboard. There's nothing in clipboard. Okay. Let me close this. Okay, I'll just type it because that should be user libraries. Then it's Python 3.6. I hope I'm getting this right. Site packages. System dot path. Let me cross my fingers and I hope that's there. Okay, we've missed something in the path. Okay. User library program 3.6 have site packages. Okay, we have site packages right here. We have an hyphen instead. Okay, that's that. Then what is the CSS path used by the script? So the CSS path used should be somewhere right here at line 21. Let's get back here. At line 21 you have this CSS path, and once again my mouse isn't functioning in this virtual machine, so I'll just be reading the lines. So at line 21 you have this CSS path variable. So this is the path inside the quotes. So after the command is executed, there's a command above the commands above. After they are executed, the command output is then appended to this CSS file, which is a legitimate part of the firewall, of the GlobalProtect firewall. So that CSS path. Okay, come on. Okay. Let's come back here. Slash then we have it's app web, not web app. That is SLV what? SLV something, SLV PN docs. Is really tiresome, but I have no other option. My mouse isn't functioning in that virtual machine. I hope you guys are not going through the same kind of problem. GlobalProtect, then portal, CSS, then Bootstrap. I hope that's it. I think so. It's loading. Let's give it time. Okay, that was correct. We got the path correct. Where does the script attempt to remove certain license files from? That should be, where is that? Let me get back here. Come on. I can't scroll. Okay. Can I find it? It should be at the bottom, I guess. I'm scrolling from my screen, from my laptop screen, because the mouse is misbehaving once again, just in case you're wondering. Okay. Let me drag it there. Okay, that is here in line 96 right here. So that is this the line 96 inside these quotes, the opt pan config management licenses. So the specific files it targets have the file names that match the pattern, this PA_VM, anything which has that particular pattern. So this pattern is likely to represent license files associated with the Palo Alto virtual machines. So by attempting to remove these files, the script might be trying to disrupt the licensing checks or prevent the software from enforcing licensing restrictions on a virtual machine environment. So that's just that. Let's go back here and let's just write that. That should be in up to then it was Palo Alto networks config. So CFG, then management, I guess, and licenses. Yep, that's it. Okay, we're missing something. Okay, what happened to? Okay, the site just went blank. Give me a sec. So I'm back in the site, and let's type the path for the licenses. So that was in opt and config, then management, which is that way, then licenses. So that's the path. I'd like to know if you guys are experiencing the same problem that I'm having. So something seems to be amiss right here. Opt pan config licenses. Pan config management. Management licenses. Okay, I have a typo right there. Okay, that's that. So as I was saying, let me know if you guys are experiencing the same problem with the virtual machine, because when I'm in this virtual machine, my mouse just keeps on disappearing. As you can see here, I can't see my mouse, but outside here it's visible. In here, inside this notepad, I can't see my mouse, my cursor. I mean my cursor. So yeah, let me know if you guys are experiencing the same problem with the virtual machine. So on to the next question. What specific signal does the protection function respond to? So let's check that here. What should the answer format be in? Okay, just the signal, the specific signal. So that should be this sigterm in line 84. Assume the function, but this particular sigterm right here, that's sigterm. So the protection function is in this script responds specifically to the sigterm signal. So this line 84 right here, it registers the stop function as the handler for the sigterm signal. So sigterm is a common signal that is used to basically to terminate processes. But unlike the sig kill, the kill9, which we usually do on Linux, sigterms terminates the process gracefully. So when sigterm is received, when sigterm is received, the stop function is invoked. So this function checks if system dot path exists, and if not, it rewrites its original content to restore the file, thus maintaining the script's persistence. So this design basically just restores the malicious code in the system path if it's deleted, thus protecting itself from removal. I wish I could show you the functions really well, but then again, that's not possible. So let's just come back here. That is sigterm. Okay, that was right. So we have sigterm, we have sigkill, we have those different types of signals. Okay, let's proceed. What function is responsible for protecting the script itself? So that's just basically this protect function on line 74. So let's come here and do okay, protect function. Okay, that was correct. What type of pattern does the script search for within the file, within the log files? So let's come back here. I'll have trouble scrolling, but let's see. Okay, at line 28, this shell pattern equals to the that image, then that regex pattern. So let me just okay, can I okay, let me just come back here. So we have image, then it was a backslash, then square bracket, then parenthesis, then another square bracket, then the regex itself. So it was checking for lowercase, then uppercase, then numbers 0 to 9, right? Then this, which is usually used in a base 64 encoding. Then now we have the closing square bracket, then parenthesis, the backslash, then the closing. Let's see if we got that right. I guess it's really it's loading. Let's switch to see if we got it right. Okay, that was correct. So basically this line allows the script to scan the log file for commands embedded in base 64 format inside that particular image tag. So when the script encounters a match in the log file, it treats this as a base 64 encoded command. The encoded command can then be extracted, decoded, then executed on the system. So this type of technique right here that you're seeing here is often used to hide commands or instructions in plain sight, allowing for potentially malicious instructions to evade basic text-based detection systems. So when you do this particular base 64 encoding, text-based detection systems can't detect this as a malicious code. So thereby we just the threat actor will be hiding the command in a way that the text-based detection systems can't get it. And there was something I wanted to show you guys. Let's see if I can drag this. Okay, I can't drag it. Oh no, this is terrible. I can't drag it. Okay. Here we are. So what I wanted to show you guys was that from line 34, from line 35, I mean, the base64 code is the encoded command is decoded. Then after it's decoded, it is stored in the output variable. Then we open the CSS path, which had that particular CSS file that we were talking about earlier on. Then it takes that particular the output of that command and writes it in that particular CSS file, but it writes it in those comment. The comment, as you can see in line 39, the f dot write, it writes it as a comment. So this might just be a way to write the output of the command in a stealthy way, to log the output of the command in a stealthy way that doesn't raise suspicion when there are scans going on, when they're scanning these particular files. So yeah, so just know that you can encode your commands to something like base64 to evade detection. Yeah, so that's that about that base64 encoding. Then which log files does the script read from? So where should that be? Can I find that? Let me try scrolling. Okay, it's scrolling. Okay. So that should be right here in we can take, let's say, line 50 40 45, I mean, in let's see which specific log file does the script read from. So yeah, that is line 48. These are log pan SSL VPN error. So I think this is just reading the errors that might be from the Palo Alto VPN or that particular global protect device. So you know very well when you get verbose errors on something, you can it gives you an attack surface to know what's not happening or what's happening. So by gaining errors, by getting those particular errors, you can use them to elevate your attack. So that's just that. So that should be in the var log Palo Alto networks. Okay, pan. Then SSL certificate, VPN, okay, that was an underscore ngx underscore error.log. I guess it was that way. Let's see. It's taking time. Okay, that was that. So we finished the questions that were here in this particular Upstyle Backdoor. So basically, the script that we've just analyzed, this particular script, is a script that was used in the exploit of CVE-2024-3400 in the GlobalProtect firewall devices. So I guess there were two scripts that were used in that particular exploit. This was termed as update.py, of which was the threat actor, whom we identified as UTS 0218, tried to deploy this particular script, I think thrice, but it wasn't successful. Yeah, but this particular script was one of the two scripts that were used in that particular exploit when the threat actor gained his foothold in the GlobalProtect firewalls. So yeah, that was that. I'll leave a link that details much more about this particular CV where this particular backdoor was used. So yeah, that was Upstyle Backdoor. I'll see you in the next video.